My name is Megan Flynn. Today I will be talking to you about polarity and electronegativity. What is polarity? Well, polarity describes how much of a partial charge a molecule has. When a bond or molecule is polar, it has an unequal sharing of electrons. When a bond or molecule is nonpolar, it has an equal sharing of electrons. Electronegativity is the tendency to draw electrons in a bond towards itself. It's found on the periodic table. It is used to measure polarity, and as the difference in electronegativity increases, so will the polarity. On the periodic table, you will find electronegativity right under the name of the element. To figure out if a bond is polar or nonpolar, you will use these easy steps. First, find the electronegatiivity for each atom. You will then subtract the electronegativities, and finally, if the difference is above 0.5, that means it's polar. If it's below 0.5, it's going to be nonpolar. Here are some examples of bonds being determined polar or nonpolar. First, N and H. You will find nitrogen's electronegativity and then hydrogen's. You will then subtract the two, and in this example you get 0.5, and that helps us determine that it's going to be polar. The next example is CCl. You will find the two electronegativities and subtract them. 3 minus 2.5 is 0.5. This also means that it's polar. For the last example, S and S, they will have the same electronegativity, and when you subtract the two, you get a difference of 0, meaning that it's nonpolar. Polar molecules. Polar molecules have a separation of partial charge that creates a dipole moment. Polar molecules must contain polar bonds, but remember that not all molecules with polar bonds are necessarily polar molecules. Here are some examples of molecules being polar or nonpolar. In CF4, it is going to be a nonpolar molecule because all 4 bonds between C and F are polar. When all 4 of these are pulling in different directions in polar ways, they're going to create a nonpolar molecule because they all cancel out to create a nonpolar molecule. In H2O, it's going to be a polar molecule. This is because when you are determining if a molecule is polar or nonpolar, you're going to check the Lewis dot structure of the molecule. In the Lewis dot structure, if there is clear symmetry, then it's going to be a nonpolar molecule. If there is no symmetry, then you know it's going to be a polar element. This is because that when the symmetry is even, all of the polar bonds are going to cancel out to be nonpolar, like in CF4. But in H2O, where a bent shape is formed and the 2 hydrogens are not symmetrical, then it's going to be a polar molecule, even though the 2 bonds are nonpolar. Recap. Today we talked about both polarity and electronegativity. Polarity describes how much of a partial charge a bond or molecule has. Electronegativity is the tendency to draw electrons in a bond towards itself. Electronegativity is used to determine if a bond is polar or nonpolar and is found on the periodic table. There are 3 steps determining if a bond is polar or nonpolar. The first step is to find the electronegativities. Then you'll subtract the 2 and determine if it's polar or nonpolar based on the difference. If the difference is above 0.5, it's going to be polar. If it's below, it's going to be nonpolar. Also, when you're determining if a molecule is polar or nonpolar, you're going to use the symmetry of the molecular shape and determine if the bonds are nonpolar or polar, and use that to determine if the molecule itself is polar or nonpolar. Thanks for watching this recap on polarity and electronegativity in Chapter 10 of Enriched Chemistry.